So, good morning. So, after 11th standard studies, we are going to discuss our 12th standard portions. What is the end of first unit? Everyone knows magnetism. Once we understand magnetism thoroughly, that is very much easy to understand about the 12th standard first chapter, Electrostatics. So what are all we have studied in magnetism, we are going to be studied in the electrostatics. Very easy chapter. In the electrostatics, we are going to study about electric charges, Coulomb's law. We already studied Coulomb's law in magnetism also. Electric field, electric potential, capacitance, and then finally, as usual, the problems. So these are all the things in the electrostatics. What is electrostatics? Statics is the word related to mechanics. Why the statics comes here? It is clearly understand that the heading itself, we are going to study about the charges which are at rest. Anything at rest, we call it as static position. Since charge is at a static position, this is called electrostatics. Therefore, in this chapter, we are going to study about charges, but the charges must be at rest. That is the thing as far as the electric charges is concerned. There exist two types of charges. So, we can obtain charges by way of friction. That is called electrostatics. Friction means the topic related to statics. So, we have to make contact with other. We can take the charges. The word is very important. We can obtain. No one can be able to create the charges. There exists two types of charges, positive and a negative. So usually wherever you go, in the magnetism also, there are two types of poles. One is north pole, another is called south pole. Similarly, charges are also two types. One is called positive charge, another is called negative charge. Everyone understand about like charge repel each other, unlike charge attract each other. So quite obvious. That is also naturally also we can see in our life also. The father is very much attached to our daughters and our mother is very much attached to our sons. That is a usual happening. That is by nature also. Like that, like charges repel each other, unlike charge attract each other. Like charge means positive and positive, or negative and negative. Unlike means one is positive, another is negative. They attract. When two substances are rubbed together, transfer of electron from one substance to the other substance, which losses become positively charged and the other negatively charged. Very easily think. Take a glass rod. So anything, any material is loaded with atom. Atom possesses both positive and negative charges. If a glass rod are rubbed with the silk cloth, I take a glass rod, this is a glass rod, I take a silk cloth, if it is rubbed out, so this silk cloth take all the negative charges from the glass rod. So the glass rod retains the positive charge. So this is positive, the rubbed out is negative charge. Therefore, the glass rod retains the positive charge. Similarly, ebonite rod, take a ebonite rod. The ebonite rod, this ebonite rod, that may be rubbed with the fur. Fur, you know, any wool or like that, fur. Take a ebonite rod and it is rubbed with the fur. What happened? All the positive charges are removed from ebonite. Therefore, the abnate rod retains the negative charge. So, all the positive charges go out. So, in glass rod, all the positive charge retains. Here, all the negative charges are retained. This is a way we can obtain charges. These charges are obtained by rubbing method. This is a usual method. Otherwise, electrostatic machines are there. The electrostatic machines are very much useful to obtain charges in large scale. That is a mission. This is a way you have to understand what is positive and negative. So this is an example I have given just now. Glass rod rubbed with the silk, ammonite rod rubbed with the fire. Thus a body can be charged by friction. That is called electrostatics. So I want to find out what are the properties of charges. So you have to find the difference between the properties of lines of forces and the properties of charges. What are the properties of charges? The first property is called quantization. What is quantization? Usually, any charge can be represented by a letter small e. Small e is the representation of charge. The charge is there. It should be represented by a minimum value small e. The value of e, everyone knows, 1.602 into 10 power minus 19 coulomb. So this is the value of charge. A single charge can be represented. Actually, I explained here. Quantization very important. If it is a single charge, that should be represented by letter small e. The value of e, 1.6 or 1.602 into 10 power minus 19 coulomb. If we take a system, the system may be more than a single charge. For example, in a particular system, 18 charge or 19 charges will be there. If any system contains more than a single charge, that should be represented by Q. Q is nothing but N into E. This is called quantization of charge. E is a fundamental thing. If there is only one charge, that will be represented by letter E. In a particular system, there are 18 charges there mean that can be represented by 18E. So what does it mean? That is N is nothing but 1, 2, 3, like that, etc. So whatever may be the system, we cannot understand what is how many charges it contains. So that should be multiplied, simple multiplication, that is called quantization. Q is equal to NE. So from which the problem may be asked, how many charges are there? N is equal to Q by E. This is called quantization of charge. So N into E is called quantization. So another thing, what is conservation of charges? Charges can neither be created nor be destroyed. Just now I told you that we can obtain the charges, but we cannot produce. No one able to produce charges. Charges can neither be created nor be destroyed. How? That is usually possible. For example, a system consists of 14 charges. Q is equal to 14. E. So it is divided into 3 portions. 1, 2, 3. The first portion has 7 charges. Second portion has 3 charges. Third must be 4. What is the total charge? 7 plus 3, 10 plus 4. This is called total charge remains a constant. That is called conservation of charges. In a particular system, the total number of charges remains constant, or charges can neither be created nor be destroyed. So many examples also you have studied in your nuclear physics and also in chemistry also. The 92 uranium. Uranium has 92 electrons that may be divided into 56 barium and 36 krypton. So we already studied in the nuclear fission. So 92, here 56 plus 36. This 56 plus 36 will give, that is 56 plus 36 will give 92. So the total amount of charge remains constant. What is 56? Number of electron of barium, and 36 number of electrons of krypton. Even though uranium breaks into 2 lighter elements, the total electron will be 92. That is a concept. Be careful. So, this is a given that quantization. The charge of electron or proton are denoted by E. Why I put what is a proton or electron? Both are E, because both the magnitude will be the same. Only electron have negative charge, proton have positive charge. The smallest charge, all other charges are integral multiple of this E. That is Q is equal to Ne. That is called quantization. Just now we have discussed. Conservation of charge, total charge of an isolated system always remains conserved. Unit of charge always coulomb. Another property you can use it, the additive law. The additive law is not actually, everyone knows, so that I am not given in the slide. Additive law means there are plus 4Q charge will be here. So minus 3Q charge means what is the net charge? Net charge is plus 1Q charge. This is called additive, just like our algebraic addition. So you have to take the two different charges, plus and minus. You have to subtract from higher value to lower value and put the sign of higher value. That is the usual procedure. The another important law is called Coulomb's law. Coulomb's law we have discussed clearly in magnetism also. Similarly, we are going to discuss Coulomb's law in electrostatics. One problem definitely comes in this area. In any form, Q is equal to Ne, N may be Q by U, that is one type. Now calculate the force is another type. Force is given, calculate the individual charges. These are the type of problem asked usually in the NEET examinations. So Coulomb's law, there are two charges. The charge has an Q1, the charge is Q2. If they are separated by distance R. What is the difference? There in magnetism, M1 and M2, they are separated by distance small d. Here it is converted into R. That is the difference. Two charges. If Q1 positive, Q2 is also positive means they experience a repulsive force. If Q1 negative, Q2 positive, attractive force. Force also two types, attractive and repulsive force. So generally Coulomb stated that force between the charges is directly proportional to product of the charges and inversely proportional to square of the distance between them. This law is called Coulomb's law. F is proportional to Q1, Q2 by R square. Whatever be the charge, the force depends upon these charges. So now to remove the proportional sign, I have to add one constant K, that is Q1, Q2 by R square. Where K is a constant, the value of K 1 by 4 pi epsilon. So there we have put mu by 4 pi. Here 1 by 4 pi epsilon. This epsilon is not a single, it is a combination of epsilon naught and epsilon r. So generally epsilon means permittivity. So there mu permeability, that is a difference. I already discussed in the magnetism itself. There is the ability of the magnetic force that can pass through. I have given an example. Take a glass plate. Above the glass plate, if you take a bulb, under the glass plate, if a wire is connected, no, bulb cannot be glowed. Whereas in the glass plate, I took iron filings. Under the glass, I move a magnet, definitely iron filings disturbed. What does it mean? It is clearly that magnetic force can pass through it. That is the ability of magnetic force penetration. That is called permeability. Here it is not possible, so it is called permittivity. This permittivity, epsilon is equal to epsilon naught into epsilon r. What is epsilon naught? That is permittivity for free space. Epsilon. What is epsilon r? That is relative permittivity. That is called relative permittivity. Epsilon r is called relative permittivity. Epsilon naught is called permittivity for free space. The value of epsilon naught 8.85 10 to the power minus 12. I have given with along with the unit you have to remember. Relative permittivity for air medium always equal to 1, other medium more than 1. Even though for iron that may be equal to 1 lakh. Imagine relative permeability. Relative permittivity of iron is more than a lakh. So this is I have given in the table. K is equal to Q1 by Q2 R. The value of 1 by 4 pi epsilon, that value also I forget. This 1 by 4 pi epsilon naught value 9 into 10 power 9 Newton meter square per Coulomb square, along with the unit you have to remember. 1 by 4 pi epsilon naught value 9 into 10 power 9, that is a constant. Why you have to remember? In order to solve problem, you need not use so many mathematical path you can avoid. Directly we can put 9 into 10 power 9. Epsilon naught permittivity for free space 8.85 10 to the power minus 12 Coulomb squared per Newton meter square. That is a reverse. Coulomb square divided by Newton meter square. So if you are knowing the unit of this Newton meter square by Coulomb square for permittivity of free space, that is a reason because it comes in the denominator. If it goes in numerator, C square comes in the numerator, Newton meter square comes in the denominator. Then force equal to 1 by 4 pi epsilon naught Q1 Q2 by R square for air medium. If it is on any medium given, the formula can be modified by 1 by 4 pi epsilon naught into epsilon r. That is epsilon is equal to epsilon r relative permittivity for air medium is equal to 1. Therefore, F is equal to 1 by 4 pi epsilon Q1 Q2 by R square for any media. If it is an air media, we have to put epsilon naught alone. For any media, we have to put epsilon alone because epsilon is equal to epsilon naught into epsilon r. What is the superposition? So more than two charges, when a number of charges Q1, Q2, Q3, etc. are placed, then each exert a force on all other charges. But take Q1 exert a force on Q2, Q3, etc. Similarly, Q2 did they exert a force on Q1, Q3, etc. Like that, each charge exert a force on other charges. The resultant force on a particular charge is the vector sum of the forces exerted on it by all other charges. For example, if capital F vector is the net force on Q1, then we have F1 is equal to F12 vector, this is F1 is equal to net force, F1 is equal to F12 plus F13 plus F1n. The force between two charges is not affected by the pressure of other charges. That is the thing. If I take a Q1 charge alone, we have to find the value. Somebody asks question, suppose Q2 is also there. That may be affected the net force. It won't. The pressure of other charges won't affect the net charge. We have to take how many charge, which charge, particular charge you are taking, that charge simply vector sum. F1 is equal to ultimate. What is electric field? The next one we have to discuss about the electric field. So this is an important thing, electric field. There is a force we have completed, then electric field. This electric field very similar to that of, we have already studied two chapters in 11th standard. One chapter on gravitation. So we have studied about gravitational field. After that, in the same 11th standard, we have studied about magnetic field. Very similar to that of that fields, the electric field also defined. It is a space around a charge in which the electric influence is felt. in the previous definition, in which gravitational influence is felt where gravitational field is there. In which magnetic influence is felt where the magnetic field is defined. Here, electric influence is felt where electric field is defined. What does it mean? We take a plus Q charge here. If there is a charge Q, how can I understand? So I have to put a test charge Q0. Q0 is called test charge. The charge very much useful to us whether plus Q charge is present or not. If I take a test charge plus, it has repulsive force. If I have a test charge minus, we have attractive force. The force of attraction or repulsion may be decreased as the distance increased. If a particular distance is there, after this force will be there. Beyond that distance, no force is, electrical force is experienced. So what is the space? This space around a charge in which electric influence is felt is called, this is the field. This is a field of the particular charge. Everyone has his own field, isn't it? Even in our regular life also, somebody may quarreling with you, immediately you ask them, come to my area. Why we are calling them come to the area? Because that is field. There are so many relatives are there and friends are there, they come and help. His influence is more. So wherever the influence is available, that is the field. Here, electric influence is available. Beyond that, no attractive force or repulsive force is there. That is called electric field. How the electric field can be measured? So kindly make note. We are not bothered about the definition here, because as far as a NEET or any entrance examination, they won't ask the definition. We know the solution only. So, what is the electric field? How it can be measured? Electric field can be measured by the force experienced by unit positive charge placed at that point. The electric field can be measured by putting a plus Q charge, unit positive charge placed at that point. What is the force? That is actually happened. So suppose it is a charge. I take a plus Q charge here. In the charge I have Q0 will be the test charge. They are separated by distance d means. By Coulomb's law, what is the force? In air medium, 1 by 4 pi epsilon naught Q0 by r square. This is a formula simply. 1 by 4 pi epsilon naught Q by Q0 by r square. This is for air medium. What is the definition? By the definition of electric field. Electric field is defined as force experienced by unit positive charge placed at that point. Therefore, by definition, Q0 is equal to plus 1. Therefore, the formula can be modified as 1 divided by 4 pi epsilon naught Q by r square. What about Q0? Q0 becomes 1. This is called electric field. This is called electric field. So what is the formula for electric field? 1 by 4 pi epsilon naught Q by r square. How can you keep your mind? For force is concerned, 1 by 4 pi epsilon naught will be there. For electric field also, 1 by 4 pi epsilon naught is there. One different, there are two charges in numerator divided by r square. Here only one charge in the numerator divided by r square. The other charge become unity. Because the definition itself says. What is the definition? Again, it is the force experienced by unit positive charge placed at that point. Therefore, the test charge become plus 1. Therefore, F become E. The formula for E is equal to 1 by 4 pi epsilon naught Q by r square. Very clear? So, this is given in the detailed here, the slide. E is equal to limit Q0 tending to 0, F by Q0. Because we are divided by Q0. Why the limit comes? If denominator comes 0, we cannot find the solution. E vector also called electric field intensity or electric field. E may be called as electric field intensity or electric field. That is the force experienced by a unit positive charge placed at that point, or F is equal to Q into E, E is equal to F by Q. That is the important relation. So once we know electric field, that should be multiplied by a charge, that will give you a force. Once we know the force, that should be divided by a charge, that will give you an electric field. Because force always equal to electric field into Q. Or electric field is always equal to electric force divided by charge. These are the things I have to understand. Electric lines of forces. So that I already told you that you should not confuse with that. What are the properties of electric charges? What are the properties of electric lines of forces? Here we are going to discuss about electric lines of forces, the property. They won't ask what are the property. If it is in a regular examination, then maybe asked in the 5-mark question or other thing. But we have to understand the statement questions. The curve drawn in a field, tangent to it at any point gives the direction of the field at that point. But there is electric lines of forces like that. If I take any one point here, in that point I draw a tangent, the tangent gives the direction of electric field. The number of lines per unit area will give the magnitude. The particular unit area, how many lines crosses, that will give magnitude. The tangent drawn to the magnetic lines of force will give the direction. So how can you understand where the field is more? If the electric lines of forces are crowd, more lines of forces are obtained, we can come to the conclusion that electric field is more. If electric lines of forces are far apart, there is a lot of gap between the two lines, we can come to the conclusion that electric field is small. So these are the things I have to understand. It begins from positive charge and ends at negative charge. That is the thing. Electric lines of force always starts from positive charge, end at negative charge. Or it starts from positive charge, terminated at negative charge. Lines of force cannot cross each other. Since electric field at a point cannot have two directions. So there is a thing, electric field or particular point, we can draw a tangent. The tangent will give the direction of the electric field. For a particular point, electric field has only one direction. So they never intersect. There is another point to be noted. Electric lines of forces never intersect. This is a diagram I have given. This is a positive charge. This is a negative charge. So many lines I have drawn, even though they won't intersect. But the arrow mark plays an important role. From positive charge, it starts from positive charge and it terminated or ends at the negative charge. So here arrow mark outwards, here arrow mark inwards. That is it. Electric field due to a point charge. So just now we have discussed that. I have given the explanation. The point charge Q at A in vacuum. What is called a point charge? So in all these units, we are going to put a word point charge. What is called a point charge? Where charge is point, then it is called point charge. Not so. What is point charge? The dimension of the charge is very small compared to this distance. The dimension of the charge is very small compared to distance, then the charge is called point charge. So I have considered a point charge plus Q at A in vacuum. A touch charge Q naught in vacuum at R from Q. So just now I have derived the force on a test charge 1 by 4 by Coulomb's law, 1 by 4 by epsilon naught, Q1, Q2. Similarly, Q into Q naught by R square. The magnitude of the electric field at Q naught. What is the definition? It is a force experienced by unit positive charge placed at that point. Instead of Q naught, I have to put plus 1. Therefore, 1 by 4 pi epsilon naught Q by R square. The direction of E is on a radial line from Q. What is the direction? So, we go to the formula here. The direction of electric field, if I take Q naught is positive 1, it is repulsive. outwards, radial line. This is a radial line. It is outwards. If I put Q naught as negative, it is always towards A or away from A. So it depends upon the charge. The direction of E is on a radial line. Radial line means along AB, pointing outwards if Q is positive and inwards if Q is negative. Field due to several point charges, because this point we noted the Q naught. The Q naught cannot be plus and minus. The Q naught always positive. Why? Only the test charge may be plus or minus. Be careful. We cannot take Q naught as positive or negative. The definition clearly tells you that the force experienced by a unit positive charge placed at that point. Therefore, Q naught is always plus 1, not minus. If Q is positive, it along away from AB. If Q is negative, along BA. That is the thing we have to understand. Field due to several point charges. Just now we have seen what is force due to several point charges. Similarly, what is the field due to several point charges? Simply vector sum. E1 field due to Q1, E2 field due to Q2. Everyone has his own area. Q3, E3. So the total electric field become, simply we have to add the vector sum of E1 plus E2 plus E3 etc. up to E. The electric dipole. So this is an important thing. We have to understand the dipole. So in magnetism also dipole. What are they? North pole and south pole. No monopoles exist because Gauss law clearly says total charge enclosed by the surface always equal to 0. There, the total pole we have discussed in the 11th standard syllabus itself, the last topic magnetism, that because it comes 0, no monopoles exist. Similarly, here also what is dipole? Very similar to that of magnetism, electricity also to dipole. The dipole is nothing but two equal and opposite charges, that is plus Q and minus Q. So the magnitude of these two charges same, Q and Q. One is positive, another is negative. Separated by a very small distance 2D. Usually the distance is denoted by letter D. Why I put 2D? Very similar to the top length of the magnet. Length of the magnet is always taken as 2L. So to parallelize the magnetism along with electricity, we are taking also 2D. It is also for calculation simplicity. Two equal and opposite charges separated by a very small distance 2D constitute a dipole. This is a dipole. What is dipole moment? Dipole moment can be calculated product of any one of the charge. This is also Q, this is also Q. Take any one of the charge into the distance Q into D, 2D, or it is a product of any one of the charge and distance between them will give the dipole moment. The formula for dipole moment, P is equal to Q into 2D. Dipole moment is a vector quantity, but whereas charge is a scalar quantity. So these are all the things I have given in this. Dipole moment P is equal to Q into 2D. The direction of minus Q to plus Q. Field due to a dipole on the axis. This is the important thing we have to understand. What is the electric field due to a point on the axis of a dipole? That is axis. Very similar to that of magnetism. Electric field due to axis. So take a dipole. Similarly, we know the table itself. Everyone knows minus Q and plus Q. It is better to understand always minus Q and plus Q. These two equal and opposite charges separated by a very small distance 2D constitute a dipole. This is a center O. Therefore, this must be D. This is also. So this is called axis. In the axis, I consider a point P. The point P may be at a distance R from the center of the dipole. So what is the electric field at P due to dipole? We cannot easily find out what is electric field due to dipole from the center, because in order to find out field there must be a charge. The charge is placed at the end. Therefore, what is the, suppose I take A, B. Field, electric field E1 due to plus Q charge at P. The same formula, 1 by 4 pi epsilon naught charge divided by distance square. That is BP square. The BP is nothing but the total distance is R up to this D, R minus D the whole square. The direction, we know it is always plus 1. So along BP. So in our examination also, the direction plays an important role. Why the direction is along BP? Because we have to put a plus 1 charge at P. What is the force experienced? That force will give field. Therefore plus 1. This plus repulsive. The direction of the force is along BP. That is the thing we have to understand it. Similarly, what is electric field due to minus Q charge? That is E2. The same formula, 1 by 4 pi epsilon naught Q divided by AP square. AP square means the total distance R plus D. R plus D the whole square. So this is called even. But we have to find out the resultant electric field. We want to find out what is electric field from O. What is this direction? This direction is along PA. This direction is along PA. Why? Because it is attractive force. So the net force due to dipole, that means from at O, what is electric field? We have to E1 minus E2 we have to find out. Why we have to find E1 minus E2? Because plus Q is very nearer to plus 1. Therefore, this force is more than that. Therefore, we have to subtract it. If we are subtracted, 1 by 4 pi epsilon naught Q or Q by 4 pi epsilon naught is a constant. 1 by R minus D whole square minus 1 by R plus D whole square. We have to take LCM and everything. We can get the final solution as E is equal to 1 by 4 pi epsilon naught 2 PR by R square minus D square the whole square. So you have to remember here, this is this important formula for solving problem. So this is the electric field due to a point charge or due to dipole. Dipole placed at the point R. 2P. P is called dipole moment. Q into 2D replaced by P. P is always equal to, you have to know, P is always equal to Q into 2D. So in the derivation, Q into 2D replaced by P. Therefore, 2P, that is Q into 2D. Therefore, 2PR by R square plus D square. For a short dipole is short. What is a dipole definition? Two equal and opposite charges separated by very small distance constitute a dipole. So, we know here 2D itself is very small. What about D? Very, very small. So, that can be neglected. Therefore, this D can be neglected. Therefore, the whole system become R to the power of 4. Therefore, R getting cancels. We get E is equal to 1 by 4 pi epsilon naught 2P by R cube. This is for short dipole. Or generally, we have to know the formula 2PR by R squared minus D squared the whole square. Why I am telling that? In future, you have to keep your mind so many formulas. So we have to understand. If you are understanding it, very simple. What is dipole? Two equal and opposite charges separated by a small distance. What is dipole moment? One of the charge into distance. Q into 2D. Q into 2D replaced by P. What is called P? Dipole moment. So as far as the point placed on the axis of the dipole means, the numerator 1 by 4 pi epsilon it is a common. 2PR by R square minus D square the whole square. For a short bar magnet, simply 2P by R cube. Similarly, what is a electric field due to the point on the equatorial line? What is an equatorial line? Here also I take a minus q charge here, plus q charge. So our bisector, this is also, we have to bisect the line by two equal parts. That is called bisector. So the total distance of this dipole, we know 2d, this is the center main, this is d, this is d. So I already told you that in order to calculate the electric field, that should be related to the charge. Even though the point P I consider here at a distance r from O, we cannot find directly for OP. We have to concentrate it with the Q. Therefore, electric field due to plus Q charge. Here also plus, here also plus. This can be repelled. That is called electric field E1. Similarly, I have to find out what is the field due to minus Q charge. This is plus, this is minus, this is the E2. So we have to find out the resultant. What happened? We have to extend and complete the parallelogram. The diagonal will give the electric field. So this is D, this is R means. What is this value? Simply R square plus D square square root. Therefore, what is field due to plus Q charge? 1 by 4 pi epsilon naught Q by this distance square. That is R square plus D square. What is field due to minus Q charge? The same formula, 1 by 4 pi epsilon naught Q by R square plus D square. Because R square plus D square square root, the whole square. Therefore, square root gone. We are getting only R square plus D square. Simply substitute this and we have to find out the resultant electric field, the diagonal. So many calculations. We have to find the final solution, 1 by 4 pi epsilon naught. There we are putting 2pr. Here only p divided by r square plus d square whole power 3 by 2. That is you have to remember by yourself. R square plus d square whole power 3 by 2. For a short bar magnet, d is very much less than r. Therefore, d can be neglected. If d square can be neglected means r square whole power 3 by 2. Kindly go through. R square whole power 3 by 2 means 2 getting cancels. We are getting r cube. Therefore, p by r cube. What is the difference between the axial line and the equatorial line? 2 is missing. So like that you have to keep your mind. If the problem is asked in the axial line, we have to put 2p by r cube. If the problem is asked in the equatorial line, simply p by r cube. That's why we can add your mind. So many problems may be asked that we can utilize this. Otherwise, it is very difficult to keep every formula in our mind. We have to understand the topic. That is called the equatorial line. That is called axial line. The first problem, I already told you that the problem may be asked in the force, Coulomb's law. Directly they may ask force or charge or sometime quantization of charge. Q is equal to Ne or N is equal to Q by E. A point charge in a uniform electric field. Charge released from rest in a field. This is a central syllabus. So I am adding here the previous classes. So after that we are having our own syllabus, state board. When you go to the NEET examination, the question may be asked in any field. We cannot restrict the topic. What is the problem of entrance examination? In entrance examination, we are having only syllabus, not a textbook. Like your 12th standard. For 12th standard, there is a textbook. Any question asked beyond the textbook, we can boldly suggest that this is out of syllabus. The mark will be given. Whereas entrance examination is concerned, not such a case. We are having only syllabus. Syllabus, we cannot restrict ourselves. Maximum, we have to understand it. So that the charge released from a rest in a field. That is the thing. I take a electric charge that may be placed in a electric field. Then F is equal to Q into E. We know the distance or the product of charge and electric field will give F. Then what happens here? So this is a diagram. Electric field plus, minus. Electric charge is always starting from positive charge, terminated at the negative charge. The force between the charge Q into E. What is Q? Charge into electric field. We know By Newton's second law, F is equal to ma. We know force F is equal to ma. From which acceleration is equal to F by m. The acceleration is equal to F by m. That is given in the side. Therefore, F by m, F, we already discussed that QE by m. Velocity after time t. We know, once we know acceleration, that should be multiplied by time, that will give velocity. Because acceleration is nothing but rate of change of velocity. That means velocity divided by time will give acceleration. Therefore, keep velocity on one side, this time goes on other side, multiply. Therefore, QU by m is called acceleration into t. This is actually velocity. Distance traveled in time t. This is a distance. From positive charge to negative charge it comes. The distance between the two places. How much is the distance? It can be calculated by using mechanics. We know S is equal to ut plus half at squared. Here u initial velocity becomes 0. Therefore half at squared. Simply half instead of a QE by m into t squared. That is the formula for finding the distance. Distance traveled of QE by m into t squared. This is the distance traveled by a charge at rest in a uniform field. Kinetic energy, work done by the electric field. We know energy, work done. Work done is told as energy. If it is a kinetic energy, because the charge passing from positive to negative, the kinetic energy is nothing but work done by the electric field. What is the formula for work done? Force into displacement. What is force? Q into E. Into displacement is Y, where Y is the displacement. So, if the electric charge at rest, we can able to find out. If the electric charge is in motion, that is a second question. That is usually the last need also the problem is asked. So, up to the acceleration, velocity and the kinetic energy, if you have charge at rest in an electric field. If any moving charge, we will see in the next class. That is a better place to stop. Remaining thing we see in the next class. Thank you.